In this video, I want to go over how Bitcoin works. I'm also going to be going over a little bit of the history and the mining process. This will be a good video for people who are new to the crypto space or just don't quite understand how blockchain technology works and want to understand. And I think it's worth understanding, especially if you're going to be investing any money into the space because so many other projects are being built using this technology. And you'll be able to delegate on your own if a project is actually doing something new or not, because there's a lot of copy and paste stuff out there since all the code is open source. So yeah, let's jump into it. So Bitcoin uses something called proof of work, which is the mechanism that completes transactions and it keeps the network secure. I'm going to be linking everything that I show you guys in this video in the description below, so go ahead and take a look if you want to do your own in-depth research more than I'm explaining. But if you want to have a decentralized currency with no governing body, there's certain problems that you have to solve, and proof of work allowed Satoshi to create a decentralized consensus mechanism, and we'll get deeper into what that even means. But another problem that Satoshi also solved in the creation of Bitcoin was the double spending problem, which is pretty much spending the same money twice. And so double spending occurs when someone alters a blockchain network and inserts a special one that allows them to acquire a cryptocurrency. And so this is just a basic understanding. We'll get deeper into this, but these are the problems that Satoshi had to solve. And so when you think about the way that we do things now, our modern banking system is what keeps track of who has what money, how much they have, who sent what amount to who, and meanwhile the government can print as much money as they want. And this monetary ecosystem is sort of a problem for citizens because banks can stop any transaction they want by freezing accounts. Banks can be slow and extremely expensive, especially compared to other technologies. And it's interesting because Satoshi actually included a secret message in the Genesis block, which is the first block that Bitcoin mined. And it reads down here, the Times, 03, January 2009, Chancellor on brink of second bailout for banks. And so this is referring to the 2008 housing crisis that caused severe economic hardship around the world. And citizens suffer through this hardship while the banks that caused the hardship were bailed out by the government. And so through this hardship, only one person was arrested for all of the horrible stuff that happened. And so the government just printed money and gave it to the banks, and that bailed them out. And when the government prints money, it's known as quantitative easing. And in 2020, the United States government printed around 40% of the money in circulation, and that's just in 1 year. And this can cause negative effects on the economy in the long term. So now, getting into how Bitcoin works and how it uses proof of work. This is a blockchain demo, and there's actually a really popular video on YouTube that I'll link below, just to give credit. But as you can see, there's a hash and we have some data. And so when I input data of any kind, each character that I type generates a new hash. And so each input is like it has its own fingerprint. And so you might be thinking, oh, what are the odds that the same hash is used for, if we type something? What are the odds that two different things will have the same hash? And the odds of that are 2 to the power of 256, and that's because this is a SHA-256 hash, and you can, I'll link some information about SHA-256 in the description below, but a SHA-256 hash is always represented by 64 characters. So if you look down here, if you count these, this would be 64 characters long. And the odds of 2 to the power of 256 it's just an unimaginably large number. 3 blue, 1 brown has a great video on this, and I will link that in the description as well. I highly recommend watching that, just because it sort of gives you an idea of how large that number is and what the odds are of something having the same hash. But yeah, so this is just an example of inputting data and how a hash is generated. Each input has its own fingerprint. So expanding on this idea of what a hash is, now we have a block. And a block has more data that we can input. It has block number, nonce, the actual data, and the hash. And remember, the hash always represents, it's sort of the fingerprint of the data within the block. And so this hash has to begin with 4 zeros in order for it to be what's called valid. And so if I go up here and I type in my name, you can see it no longer begins with 4 zeros, the background has turned red, and we now know that this block is invalid. And we'll get into a deeper understanding of what that means just in a sec. But if I wanted this hash to begin with 4 zeros, this nonce is the place that I would do that. And so we're going to do something called brute forcing, where we just type until we get the right one, until we get a hash that begins with 4 zeros, because that's what the difficulty in this example is set at. And so in order to automate that process, we could just come down here and click mine, and it will brute force until it finds a correct hash that begins with 4 zeros. So we've seen that it's done that, and it counted all the way up to 104,332. And this is an idea of what mining is and how it's done. And the faster your computer is, the more guesses it can make, and so therefore the more money it can make. And we'll take this idea and we can go over to the blockchain section. So now that we're in this blockchain section, this is where we're introduced to something called Merkle trees. Merkle tree, you don't have to remember the name. It's pretty much the concept that this hash right here, well, I guess this is the previous hash section right here. So this right here contains the hash of the previous block, the hash that makes it valid. So this is block number 1. Block number 1 does not have a previous block before it, so this previous hash section right here is just containing a bunch of zeros. And so this block number 1, though, it still needs a hash that begins with 4 zeros, and as you see, it does have one, and this exact hash right here is copied into block 2. So block 2, the previous hash section, contains the exact same hash as block number 1. And this continues on, and in this example, there are 5 blocks. It goes up to 5. And so, just as before, if I were to type in any data, you can see that this is now red. And it still contains the previous hash of the one before it, but now we have to mine this block until it guesses the correct nonce. So the nonce for it was at 1,000 or 117,000, around there, and now this is there's nothing really wrong with this blockchain. All of the hashes from the previous hash still point back to the one before it, but if we go a couple blocks back, instead of the latest block, we can go to block 3, and you'll see that not only is this block red, but the previous hash also changed in these blocks. So the data is now changed. And so what you could do is you could just mine until you see that this hash has 4 zeros again, this one does not, and that is because the previous hash is different. So you would have to mine these two. And once it's all complete, there we go. Our blockchain is made whole again. But even any change at all to these prior blocks totally messes with the chain. And so this is something called immutability. You cannot go back in time and change things that have happened in the block without having the consequence of having to use your computing power and energy. And as we go on to the next section, this distributed section, you'll actually be able to see here exactly why you can't just do that. So in this blockchain section here, as I just showed you, it refreshed, but typing anything in here changes the hash. But when you have a distributed ledger and everybody, let's say you have 3 friends or peers, peer A, peer B, peer C, they all have their own version of this distributed ledger. And so let's say I go to block 3 and I decide, okay, I want to add something different to block 3. I'm just going to add my name. I mine it, that one done. Block 4, block 5. Okay, and now we see that all the boxes are green, except for the fact that these hashes right here at the bottom are different now because there's different data. The fingerprint is different. So if you look at this, block number 3, this hash right here still begins with 4 zeros, or, well, 5 zeros. That one's 5 zeros. At least 4 zeros it needs. But if you look down here, block number 3, your peer B is saying that, oh, the data in this is different. And that's because it has a different fingerprint. And same thing with this guy down here, peer C. These two are going to have the exact same hash because they contain the exact same data. And so this is sort of a democracy we have going on here. These two agree, we have the correct data, you do not. And so, if I was to mine this again, we could then have the exact same hash. But that is how a distributed blockchain is able to tell if there are any bad actors within this ecosystem. So if you were to just come in here and go back in time and try to change it yourself, you would see that you have something different than the other guys, and they would be able to tell, and they would say, oh, he's lying. And so we take this idea, we go over to the token section, and this is sort of where you get a deeper understanding of how value is sent from one person to another and how it's immutable. So now that we're in the token section, we can see that we actually have more inputs. It's not just blank data that we were doing before, where you add just anything that you want. Now you can see that we have a transaction section, which shows the amount of money being sent by who, and who receives it. And everything still applies here. You delete something, it will mess with the Merkle tree, and everything will be messed up. If you attempt to change something, mine it, the data would still be different than the hash of your peers. And so they will be able to tell that you're lying. As you can see, the hash block 2, they're different. And so in order for us to also know how much everyone has, we're going to need to add something called a Coinbase transaction, which is in this next tab. So this Coinbase transaction is the final step in understanding all of the information that is added to a blockchain in every block. The Coinbase transaction is usually the first thing that happens inside of any given block. So we can see that this is block number 1. Before block number 1, there was no money in circulation. So this block, it still needed a valid hash, and it looks like the maximum amount in this ecosystem is 100. As you can see, 100 is in all of these Coinbase transactions. And usually the person who will receive the $100, in Bitcoin's case, is the person who guesses the correct nonce, which provides a hash with 4 zeros. And that's not exactly right, but that's sort of the idea behind it. And so it looks like Anders was the one who could guess the correct nonce, and he received $100 for it. And before that, there was no money in circulation, so his $100 is all that exists. So we go over to block number 2, and we can see that the only person able to spend money is Anders, because he's the only one with any money in this ecosystem. And he, again, looks like he guessed the correct hash, and he received $100 again for correctly guessing that hash. So he sent money to Sophia, Lucas, Emily, and Madison. They can now spend the money that they received, and we know where the money came from. We know exactly how much Anders has, and we can now see where the flow of money is going in this ecosystem. And there's actually platforms out there that keep all of this data for you, such as a block explorer. So this is Blockstream. You can see every single block that happens all the way down to block number, all the way down to the Genesis block. And so it says search for block height, so we can go all the way to block 0. Block 0, here we go. And so this, there's one transaction in here, and it is the Coinbase transaction, as you can see. So this is the real Bitcoin blockchain explorer. So very similar to what I'm showing you here. But at this point, we kind of have a basic understanding, or a full understanding, of how a blockchain works. And so Bitcoin takes this concept of a blockchain, the immutability, the hashes, and it has its own specific rules. And so getting into that, that is known as tokenomics. So the tokenomics of Bitcoin are a bit different, and now we will get into that. So as I was showing you guys, this is block 0. And as you can see here, the amount of zeros needed for this block to be valid is way more than 4. Well, it looks like it. I'm not going to count them, but you get a rough idea. And nowadays, the difficulty of each block is much higher. So right here you can see there's a lot more zeros, which makes it more difficult. And the difficulty of how hard these blocks are to mine changes roughly every 2 weeks. I'll get into that just in a sec, but I want to mention that right here we could see that 50 Bitcoin was in this Coinbase transaction. That was the maximum amount of Bitcoin that you could give yourself. Like we said before, if you can guess the right hash, this being the hash, you do that by guessing the nonce, typing 1 to an infinite amount. You come up with this hash, and you were then rewarded. We'll get into more detail about that exact process, but I just wanted to mention that every 210,000 blocks, which roughly equals 4 years, the amount of Bitcoin given out to each person who guesses the correct hash gets cut in half. And so right now we see 50 Bitcoin. Let's go to 210. Well, there's way more transactions in here, so I guess you'll just have to take my word for it. The amount of Bitcoin should be cut in half. So the Coinbase transaction should be 25. And so maybe it wouldn't be this block. Maybe it would actually be the next one. There's shows you all the transactions. But yeah, like I was showing you guys before in this blockchain demo, this is the live version of the actual blockchain, and you can go search the blockchain yourself. So if you've ever sent money on Bitcoin, this is where it ends up. And this is the data that everyone shares and everyone agrees upon. So every 4 years, the amount of Bitcoin being produced in every block with that Coinbase transaction will be cut in half until the cap is reached. And Satoshi set the cap at 21 million. And so if you were to do the math, starting at 50 Bitcoins, every 4 years it gets cut in half until 21 million is reached. That is estimated to happen in the year 2140. Another fun fact here is that the first Bitcoin transaction didn't happen until block 170. So you'll be able to see here, just typing in block 170, there are 2 transactions in this block. And every block before 170, all the way to 0, is just going to have 1 transaction, being the Coinbase transaction. And it's speculated that Satoshi Nakamoto sent someone named Hal Finney, which is a very iconic name in the crypto space. It's speculated that Satoshi sent Hal Finney some Bitcoin. And this was the first block that ever contained any transaction. And getting into how often a block is processed, you can see down here that there's timestamps for each one. It's supposed to be roughly 10 minutes apart. So a Bitcoin block is supposed to be mined every 10 minutes. And this is a security feature, because if you constantly have miners joining and leaving the network, because it's a completely decentralized ecosystem, anyone anywhere is free to join. So as somebody who joins the Bitcoin mining operation, how can we determine who has the correct history? How do we know who isn't lying to us, who is not a bad actor, and who can we determine has data that we can trust? Satoshi came up with a rule of thumb that concludes that the longest and valid chain is the correct one to trust. But even then, that isn't quite enough, because somebody could just fabricate a very long chain ahead of everyone else's, and they could come up with blocks that are completely filled with data that isn't true, and that would start giving everyone false data, everybody joining the network. And so Satoshi made a rule slowing down this mining process. One block can only happen roughly every 10 minutes, because the probability of your computer being able to find a valid nonce for every block that you're trying to fabricate ahead of the current state of the blockchain. Right here, this is the block height, this is the block number. And if I try to go one ahead of that, I cannot unless I come up with a valid nonce. And so the probability of me getting ahead is not very high. And the difficulty at which a block is mined at is changed every 2016 blocks, which roughly equals 2 weeks. If each block is 10 minutes, um, the time period it would take to mine 2016 blocks is 2 weeks. And so as we can see here, this is the latest block at this moment. This is how many zeros it has, and this is what determines, this is like the block difficulty. This is the state of the network right now. And so as you know, if we go back to the Genesis block, the amount of zeros is way less. So the difficulty varies depending on who how many other miners join the network. Because if you have a bunch of miners join the network, a block becomes easier to solve. It's easier to guess that nonce because you have more people doing it. If you have one computer mining, the Bitcoin software will calculate how long it takes that computer to mine 2016 blocks, and it adjusts the difficulty so that computer can solve a block every 10 minutes. And as I said, that should equal 2 weeks. And like we used in the previous example, our hash has to start with 4 zeros. And it took my computer just a couple seconds to guess that nonce. But just imagine if we had, let's say, 100 more computers join in. That hash would be guessed likely almost instantly. And so, in order to combat this, Satoshi set it so that every 2 weeks, the Bitcoin software adjusts its hashing difficulty by looking at the amount of confirmed blocks in the network, every 2016 blocks. The software will check how fast those blocks were mined. And if it was under 2 weeks, the difficulty is increased. And if it's over 2 weeks, the difficulty is lowered. Um, and it does this, like we mentioned with these zeros, it does this by adding another zero. Now, the original blockchain, the Bitcoin block size was only 1 megabyte, which relatively is not a lot of data at all. And so if the block size is 1 megabyte, that means you cannot put more transactions in a Bitcoin block that is more than 1 megabyte. So you can only fit so many transactions in each block. And this was kind of known as the Bitcoin scalability problem. You guys can look deeper into that, but you kind of get the idea that in each block you can only put so much data in, that being 1 megabyte. And if there's a bunch of people using that network, there's going to be more of a demand for people trying to get in each block and have their data stored onto the blockchain. And so since then, we have sort of came up with a new way of doing things. Now we have something called the weight unit. And so right now the current block weight is 4 million. We no longer use block size. It's now known as block weight. And this came with an update called segregated witness, also known as SegWit. You guys can look deeper into that. That is a bit too complicated for a beginner. But this is pretty much a way of us being able to input more data into each block without taking up that 1 megabyte worth of data. But going on from this point, we will just pretend that that never happened, and let's just pretend that Bitcoin still, to this day, only stores 1 megabyte worth of data. So now to put all of this together, I'm going to try my best to explain the Bitcoin mining process. So let's say you're running a Bitcoin miner. Nowadays, people like to use a special computer called an ASIC, an application-specific integrated circuit. Bitmain is a company that manufactures ASICs. Looks like they have a new ASIC that just came out, and this is around how much it'll cost you. But it looks like it guesses 255 trillion hashes per second. And so here we can look at the total hash rate that the Bitcoin network hashes per second, and it looks like the highest that I got was 231.4 million terahashes per second, which is an extremely large number. And so, as we said before, the Bitcoin network every 2 weeks will change its mining difficulty. So you can imagine that the mining difficulty at this time is extremely hard. So to put all of this together, I want to go through the Bitcoin mining process. I'm going to get into the specifics. So let's say you went ahead and bought one of these Bitmain ASIC miners, and you went ahead and set it up. Nowadays, people really only use ASIC miners. Nobody really mines with GPUs, and that's because these machines guess trillions of guesses per second. They're specifically built for mining. They really don't do anything else besides guess trillions of hashes per second. And so let's say you also have your own node. And so I'll link this in the description, but a node is pretty much a piece of hardware that stores all of the data of the blockchain, all the way down to the Genesis block. It doesn't have to go, it doesn't have to store the full blockchain, but if you do, it's called a full node. And it's similar to how the internet uses servers. So anyone, anywhere in the world can have their own Bitcoin node, and it connects to the internet and communicates to all of the other nodes. And they propagate transactions to each other and blocks, and every node acts as a verifier of every single transaction and block. Now, every node that your node runs into while communicating is not immediately trusted. It's going to monitor and it's going to monitor it, and every time it receives a transaction or block from that node, your node takes it and verifies every aspect of that transaction. And if you send an incorrect transaction, it will not only reject the transaction, but it will also stop listening to you for 24 hours. So a node that tries to propagate false information, a node that tries to mess with the system, it gets quickly isolated. So nodes are kind of the authoritative force in this whole ecosystem. They decide what the rules are. They decide what transactions the miners get. We'll get into that right now. And the nodes are pretty much the main thing, storing all of the memory and choosing what the rules are. So let's say you went ahead and purchased a ASIC miner and a Bitcoin node. That's how it was done back in the day. You would need both to start mining. Nowadays, you go to Bitmain. This will have everything you need. You just plug this into the wall, plug it into Ethernet, and it will start guessing 255 trillion hashes per second, which is a lot, and that's why it costs so much. But it will likely guess the knots faster than other slower processors, and you'll make more money. And so here I want to take you guys through this Bitcoin simulator. This is a block simulator. This is going to take you through the exact mining process step by step. And this one is actually kind of cool because you just type in your username. If you guys come here, you'll actually see that I mined this block. And so my name is Mo. But I'm going to take you guys through another example. And so all of the data up here, this is block number 2737. I mined the last block. We're building on top of block 2736. This is the hash of the previous block that I mined before. Looks like the difficulty set at 4 zeros, and that's similar to what I was showing you guys before in this blockchain demo. Hash, hash, they're the same. So that is what allows immutability in each block. So here we see this is the block reward. The block reward is currently set at 6.25. That is actually the current Bitcoin block reward. Like we said, it gets cut in half every 4 years. And here we see that it says, although it is perfectly fine to start mining a block that solely contains your reward transaction, you may want to consider adding pending transactions from the mempool below. The more transactions you include in a block, the more transaction fees you can collect in addition to your block reward. And so the mempool, what is the mempool? The mempool is a place where all pending transactions in the network are collected. Before adding a transaction to your block, you need to check if the signature is valid, whether or not the sender has enough Bitcoin to spend. And so that's why it takes a little bit more time. And so it's telling you it's okay to start mining a block that solely contains your reward transaction. So let's say your node comes down here and tries to verify at a block insufficient balance, not enough. So this is going to take, let's say, 5 seconds. Your miner would be sitting there idle, not doing anything. So what your node knows, it at least wants to get this block reward. It's going to say, okay, we can at least put one transaction in this block and then start calculating the correct nonce, 1, 2, 3, 4, 5, with just this info. And then that would be valid. You would be able to get 6.25 Bitcoin. So the 5 seconds that it takes to do that are still valuable. And sometimes, even if you go on the BitChain block explorer, Blockstream, you might actually find a block that only has the Coinbase transaction, and that is going to be exactly what happened. Somebody was able to guess a correct nonce very fast. And so the alternative is to add transactions that are waiting in the mempool. And the way your node is going to prioritize which transactions it should add is the ones that are willing to pay the highest fee. So because you're profiting off of them. And So this is a cool visualizer that I like to use if I'm ever sending a transaction through Bitcoin or Ethereum. Ethereum is on the left side, Bitcoin's on the right. I like to come here and you can search up your exact transaction. You click on one of these guys, and it's going to have all of the information, the hash, the amount being sent, and then these buses represent each block. So we can see here confirmation time 10 minutes, like we talked about before, the amount of transactions in this block, all of the information here, the fees. So that's a cool visualizer. But let's go ahead and automate the process. Add all valid transactions to my block. Let me refresh. Not sure why that didn't work. Add all valid transactions to my block. Well, it looks like there's no valid transactions. So we can still just mine this. What it would do is, like I just explained, it would take these transactions, see which one is willing to pay the most in fees, add them to the block, and then we can start auto mining. And this process is going to take a while, so I'm not going to show you guys because apparently on average it takes 65,536 nonces. And this one does not go as fast as the previous one. But this was kind of a visualizer of how this works. And now you guys know what the mempool is. So there you guys go. That is my complete understanding of the way Bitcoin utilizes proof of work and the blockchain to create a completely decentralized, trustless ecosystem that we can all rely on, has no intermediaries, doesn't involve any government, and as we can see, for the reason at the beginning I mentioned stuff like the 2008 housing crisis, quantitative easing, is because you guys now understand that sort of the tokenomics of how Bitcoin works, and that system is debatably better in certain ways. And so I also want to mention this is my project. This is built on Ethereum. If you guys are interested, you can go ahead and look at what this is, and I will leave this in the description. Thank you guys for watching. I hope that you guys learned a thing or two, and have a good day.
Doug?
Yo, buddy. Hey, your phone sounds better this time.
Huh?
Your phone sounds better this time. I can hear you better.
Oh, okay,
I didn't call you on that Signal app. I just called you directly.
yeah. Oh, yeah, that's right.
It's much clearer. The people, the job's done. It's got to be sanded, but not yet. It's going to take a week or two for that to dry out enough to sand it. I tried. The paper just sticks. Right? You can't sand it. So they're going to pay you for the job, and just they're going to make a separate bill when we get the other done. Right? Not worried about it whatsoever. And they didn't want the other side sided in. The other side of the stairs.
Uh-huh.
They didn't want that framed in, so it's just like it was. Because I asked them beforehand, because they're still debating to take off the sideboards on the other side and paint the underneath.
Okay, then that's good. That's okay. So, if
I'll tell you, they tried to pay me right up in front of the house when they dropped me off.
oh yeah.
Yeah, I said, no, I said, Nick does that part. I said, all I do is work. I said, I don't think.
That's not involving.
But yeah, they tried paying right away, so that's kind of neat.
Yeah.
Good people.
Yeah. That's good.
But we're definitely going to end up with more to do there, guaranteed. They really, really like the job.
Oh yeah.
Yeah. So anyways, yeah, she just told me to tell you to call them.
Okay.
So you could work out the bill, right?
Okay.
So cool. Just letting you know.
Yeah, perfect. Thank you so much, dude.
You're very welcome, bud. Let me know how we make out.
Okay.